Alright, so now let's start looking at problems that are a little bit more difficult. So this is going to be basically the same thing as the problem we had before, but with one small change. So again, we're going to have some particle, A, will be moving to the right with some velocity v, okay? And we're also going to have some particle B, and it's moving toward a collision with A. There's some collision between the two. And then we see that A is going to move off at some angle theta from its original trajectory with a velocity v prime. Okay, and so this one's going to be the same, the same basic setup. So we'll say that we're given, v, we're given v prime, we're given theta, we're given ma, and we want to find the change in momentum for particle B. Okay, so again, we saw basically how to do this before. We'll set it up so that we have mass A times the final velocity of A minus the initial velocity of A. Okay, and this is our change in momentum of A, which is equal to minus the change in momentum of B. Okay, so if we do that, we see that we have mass A. So our final velocity now, okay, we're going to have, now this time we're in two dimensions, right? So we have an x component and a y component. So you can see why we spent so much time on vectors before, because now we need that. So we look at its x component here. So we see that the x component is minus v prime cosine theta, and then we also have a y component. The y component we see is straight up, so that's v prime sine theta. And then we subtract the initial velocity, which is just v in the x direction, and it has no y component. So this is our change in momentum for A. And so then we just solve this out, and so we see that our change in momentum A is just equal to ma minus v prime cosine theta and v prime sine theta. So that means that the change in momentum of B is just minus ma, or we can pull it in. So we'll say ma, and then on the inside v plus v prime cosine theta minus v prime sine theta. Okay, so again, we want to check our units. So to do the units check out, so we have a mass times a velocity times a trig function, which has no units, so that's okay. And then we check the y component too, because I might have done the x component correctly but not the y, but again we see we have a mass times a velocity times a trig function, so it's okay there. And mass B, we just took the negatives, but we check it again real quick to make sure that I didn't make some mistake in transferring from one to the other, and these are both right. And so then the next thing I check is, does it make sense? So let's see. So initially A is moving to the right, and then it's moving to the left and up afterwards. So I should have components that are left and up. And if I look at the x component of my change in momentum of A, sure enough, it's moving to the left. The y component's positive, so momentum of A checks out. So if A is up, if A is left and up, then that means the momentum of B should be right and down, and sure enough, it's right and down. So that checks out too. So again, this doesn't guarantee that we have the right answer, because we could have made a mistake in the physics, but it at least means that our answer makes sense. And so that's all there is to solving a problem like this. And now in the next video, we're going to start looking at problems that are even more difficult.